So in this question we want to find all the solutions, and that's if they exist, of x squared is congruent with 15 and modulo 967. Now that's a massive modulo, so x could be anywhere between plus or minus 483. So how are we going to go about finding that? Well, first of all, we want to find out if a solution actually exists. So the way we can test that out is by using the Legendre symbol. Now, before we use the Legendre symbol, we can see here 967, that's a prime number. So we can go straight in with the Legendre symbol for 15 and 967. Now, using the laws of the Legendre symbol, we can say that a, b over a prime number is the same as a over that prime number and b over that prime number, and then we take the product of those two Legendre symbols. So this 15, 967, 15 will prime factorise into 5 and 3. So if I bring this out to here, this will now become 5, 967 and 3, 967. So by this rule here. Okay, so now we'll solve these two Legendre symbols individually and see what we get. Well, first of all, let's look at the prime number here. The prime number is 967. So P equals 967. Now 967, that is congruent with 3 modulo 4. So we can use one of the laws of the Legendre symbol where we say if we have, for example, Q over P, we can turn that into P over Q, and if Q and P, so if Q is congruent with 3 mod 4 and P is congruent with 3 mod 4, this one here becomes, so if we have Q with P, that becomes minus P with Q. So that's one of the laws of the Legendre symbol. Now the other one we've got is, because we can see here we've got a 5 as well, if Q is congruent with 1 mod 4 or P is congruent with 1 mod 4, then the Legendre symbol Q over P, that leads us to just P over Q, and it stays positive. So let's have a look at this. Well, 3 we know is congruent with 3 with 967 mod 4, so that works. 3 is congruent, so that's our Q, and prime number is congruent with 3 mod 4, so that becomes the negative version. So we can flip that over and turn that into a minus 967 and 3. Okay, now what about this one? Well, this one, Q is congruent with 1 modulus 4. Yes, it is. And is P congruent with 1 modulus 4? No, it isn't, but it's an OR. So therefore I can flip that and keep it as a positive. So that becomes 967 and 5. So now what we need to do now, that's not just a minus, that's actually a multiply. So let's pull that as a multiply there. Now let's just simplify these off, as these are congruent with 5 and congruent with 3. This one we can simplify off. So 967 modulo 5, that's the same as 2. So that becomes 2 modulo 5. And then this one here, that's 3 over 967 becomes 1 modulo 3. Okay, so now we need to find out, is there a solution to either of these? So what we're looking for, let's look at this one first, for 2, let's write it better than that, 2 and 5. That's asking us, is there a solution to x squared is congruent with 2 mod 5? Well, 1 won't work, 2 won't work, 3 won't work, 4 won't work, 5 won't work. So this, there is no solutions. So the result of that will give us a Legendre symbol result of -1. So that will take care of that. Now let's have a look at this one. So this one is 1, 3. We'll come to the minus sign in a moment. What we want to know, is there a solution to x squared is congruent with 1 modulus 3? Well, if x is 1, 1 is congruent with 1 modulus 3. So that has a result of +1. So here we can rewrite this now. 2, 5 is -1. And then we multiply that by a minus. This is 1, so that is also 1. So -1 times -1, that gives us 1. So that tells us that actually there is a solution. So there is solutions. Okay, right, let's clear the board off and let's see if we can find those solutions. Okay, so now let's get back to the question. X squared, let's write it up here. X squared is congruent with 15 modulo 967. Now what we're looking for is x squared minus 15 is congruent with 0 modulo 967. So we want a number in here that's going to either yield 0 or 967 or a multiple of 967. That's what we're looking for. Now, as we can't factor this, this is going to make it pretty tricky to find an answer. So what I'm going to do is just try and do brute force way. So let's put some numbers in and see if we get anywhere and see if we strike some luck. Because what we'll do is if we get the positive version, we'll get the negative version for free. So x squared minus 15. So if x squared is 982, so if x squared equals 982, we've got a solution, because that will give us 967, which is congruent with 0 mod 967. But this one, that's no result, because 31 squared equals 961. So that's no good to us. So now we'll just try a number above that. So let's add 967 on that. So let's leave that one there. X squared equals, add on to 967 to that, we'll get 1949. Now, can we get a solution to that? Well, that's not looking particularly good either, because if we take 45 squared, that equals 2025. That's not quite close enough. 44 squared. 44 squared equals 1936. So again, this one is not going to work for us. So that's no good. Okay, let's try the next one. So x squared equals, add 967 onto that, we'll get 2916. Now that is looking good, because I know 54 squared will give us 2916. So with that we get a negative version as well. So we get the plus and the minus. So x equals plus or minus 54. So x equals plus 54 or x equals minus 54. And these are both mod 967. Okay, well, minus 54 modulo 967, let's turn that into a positive, so we need to add 967 onto that. So therefore this one will give us x equals 913 modulo 967. Okay, so that's our first results there, 54 and 913, both positive numbers. But we want all the solutions. So all the solutions are x equals 54 plus 967k, or x equals 913 plus 967k, where k is in the integers. Okay, so that's going to give us our final result. That's all the results to our quadratic congruence. Okay.